Good afternoon, everyone. Today we're going to talk about bricks.
It's fun.
What is a brick? It is a building material used to make walls, pavements, and other elements in masonry construction. Originally, the term brick is a unit composed of clay. Bricks can be clay bearing, sand, lime, concrete. It could be fired and non-fired. These are the two categories of bricks. Fire bricks are bricks that have been baked, kiln dried, and are known to be one of the long-lasting and strongest materials. Air-dried bricks, non-fired, or mud bricks is more sustainable. So what are the advantages of using bricks in construction? First, cost-effective. They have lower maintenance costs compared to various other building materials such as wood. In the case of clay bricks, the raw material clay is also readily available, thus affordable. Bricks are long-lasting. Compared to wood, it lasts longer as they are not susceptible to decay or destruction by insects. Bricks are considered the most environment-friendly building material. They are made from naturally occurring materials such as shale and clay. They also undergo an eco-friendly manufacturing process as most brick makers utilize natural gas and other bio-based materials in their kilns. When it comes to temperatures, bricks have better thermal mass than various other building materials, thus have the ability to regulate temperatures. Heat and cold take more time to travel through the thick mass, aiding in insulation. This helps save on your energy bill. Bricks can withstand the elements. Compared to wood, it suffers less destruction in the event of storms. Bricks are recyclable and can be used on other projects such as landscaping. Bricks made from clay are non-combustible, making them less susceptible to burning compared to wood. Moreover, the resilience helps contain fire in a room, thus preventing extensive damage. Due to their resilience to fire, decay, and bad weather, brick houses are usually charged lower insurance premium compared to those made of more susceptible materials like wood. And these are the disadvantages of using bricks in construction. First, it encourages mold growth. The fact that bricks absorb water and have rough surfaces contributes to mold growth when not cleaned properly. Bricks have inconsistent quality. It's not always possible to get consistent quality with bricks, especially when the bricks are hand molded. The quality of bricks decreases over time. Their color tends to fade with time and prolonged exposure to the sun. Clay bricks absorb water and can cause efflorescence if not exposed to air. Bricks are labor intensive. They take up a lot of time and effort to process and use in construction. Cleaning brick surfaces can be a daunting task. And bricks have less tensile strength. Compared to buildings made of natural stone, brick homes are less sturdy and are more susceptible to extreme weather conditions.
Let's watch these videos about the process of manufacturing bricks.
Bricks are often made of shale, a lightweight rock that splits easily into thin layers. Quarry machines dig 40 centimeters down to expose the shale to the elements for 2 years. This weakens it, making it easier to process once it gets to the factory. A 4-foot-high stone wheel with a steel tire grinds the shale into powder. It grinds up 50 tons of shale per hour. A screen sifts out any pieces that need more grinding. The powder goes to the pug mill, which mixes it with water. This makes a thick paste that will next go through the extrusion machine. The extruder forces the paste through a rectangular opening to form one long continuous piece called a slug. At the same time, it shaves off the crustier top layer to expose what will become the face of the brick. If this gray shale mixture is fired as is, it'll naturally produce a red brick. To engineer a different color, they coat the slug in sand mixed with an oxide mineral such as zinc or iron. Next, they texture the surface with a textured roller. This is just one of many popular designs. Then, a large knife comes down like a guillotine and slices the slug into 5-foot lengths. You might be wondering where those 3 holes came from. Well, remember how the paste goes through the extruder to form the slug? Inside are 3 pins. They make 3 holes designed to decrease the brick's weight. Out of each 5-foot length, they cut 20 3-inch bricks. The ones on the ends are uneven, so they go back into the mix to make new slugs. Next comes the delicate job of stacking these newly minted bricks to be. A machine first separates them. Then, using inflating bags, it grasps them, raises them, then stacks them. Meanwhile, the water in the bricks is starting to evaporate. To hasten that process, the bricks go into a dryer for 2 days. The dryer gets its hot air from the heat generated by the kiln, where the bricks go next for firing. The kiln is really a giant oven. It bakes the bricks at 1,040 degrees Celsius. That's almost 2,000 degrees Fahrenheit. One and a half days later, the bricks are ready. The transfer machine takes them out of the kiln. But before they go to market, a technician does a quality check. He weighs and measures a sample to see if it meets the design specifications. Bricks are supposed to absorb some water, but not too much. Yet if they repel water completely, they'll also repel the wet mortar the masons use to stick the bricks together. So to test absorbency, the technician breaks a brick in half. He weighs it before and after soaking it in water for 24 hours. By comparing the weights, he can see how much water the brick has absorbed. Once the batch gets the okay, they stack the bricks into cubes of 500 to 600. Each brick weighs 5.5 pounds, so each cube weighs in at about 1/4 ton. Brick is one of the sturdiest building materials around. It doesn't rot, fade, warp, or dent the way some other materials can. Bricks are also energy efficient. They absorb heat to help cool your house in the summer and hold heat to help keep it warmer in the winter.
Emission of huge quantity of toxic elements from brick kilns is causing serious health hazards. The brick kilns emit toxic fumes containing suspended particulate matters, rich in carbon particles and high concentration of carbon monoxides and sulfur oxides that are harmful to the eyes, lungs, and throat. According to the data gathered, the primary source of sulfur oxide is traffic vehicles, which is 55.8%. It is then followed by brick manufacturing industry, which is 28.8%. The primary source of nitrogen oxides pollutants is also traffic vehicle, which is 54.5%, and brick manufacturing industry, which is 8.8%. Also, almost 25 to 26% of food production are used for burning bricks every year, causing deforestation.
Other air pollutants from clay kilns. SPM in the fuel gases, which is generated mainly due to incomplete combustion of fuel, black smoke, or comes from fine coal, dust, ash present in coal, and burnt clay particles. Hydrocarbons and carbon monoxide due to incomplete combustion of fuel. Sulfur oxides. Concentration of this mainly depends on the amount of sulfur present in the coal, and is significant where high sulfur content coal is used. Dust pollution generated during removal and laying down of ash layer on the top of the kiln, and also due to blowing of ash stacked on the top and sides of the kiln.
The harmful effect of pollutants locally can be reduced by reduction in concentration of pollutants through dispersion of pollutants in a large area. This way, recommendations for taller chimneys are given. Tall chimneys ensure release of pollutants at a high height, which gives more time to pollutant to disperse in the atmosphere before reaching the ground. Switching brick makers to technologies proven to be more efficient and improve air quality.
Reducing the wastage of good quality agriculture soil in brick making. A. Promoting deep mining of clay for brick making instead of surface mining. On present day, only the top surface is utilized for brick making. This results in large surface area being affected due to excavation of soil for brick making. Deep mining of clay can reduce the area affected due to excavation of soil for brick making. B. Promoting use of waste materials like fly ash in brick making. The use of waste materials such as fly ash, boiler ash, stone dust, etc. can reduce the use of
It's
good
fun.
quality agriculture soil in brick